Hi everybody! Now that we have the basics of using inverse trig functions, we want to solve some application problems. Let's go back to our scenario of hanging a security camera. Let's say a security camera mounted at a spot 8.2 feet high on a wall needs to focus on a spot 4 feet high that is 12 feet away from the camera. What angle of depression should the camera be aimed? The first thing we need to know is angle of depression versus angle of elevation. Notice that both the angle of depression and angle of elevation are determined from a horizontal line. From a horizontal line, we look down for the angle of depression. From a horizontal line, we look up for an angle of elevation. I think it'll help if we draw a picture to go with our scenario. I have my camera. We'll say that the height of the camera is 8.2 feet, and the height of the point we're trying to focus at is 4 feet. The distance between those two is 4.2 feet, which is the height of our triangle. Our horizontal distance is 12 feet, and we are looking for our angle of depression theta. Because we have both the opposite and the adjacent, we can use tangent to find our angle. We'll say that the tangent of theta is equal to 4.2 over 12. Using our inverse function, we have the tan inverse of 4.2 over 12 is theta. Let's go to our calculator to find our angle. The first thing I want to do is check my settings. So on the settings, it says it's in radians. I'm going to change to degrees. Then I can either type in tan inverse, and I'm going to put parentheses of 4.2 over 12, or I can open my keyboard, go to the functions, look at the inverse trig functions, and select tan inverse. In both cases, I find that theta is 19.29. I'm going to call that about 19.3. So this says our angle of depression for our camera should be about 19.3 degrees. Our next question says a ramp that is 60 inches long has a vertical height of 39 inches. What is the angle of elevation of the ramp? Again, we'll start by drawing a picture. We know our ramp is 60 inches long and it goes up 39 inches. Let's call the angle of elevation alpha. In this triangle, I have the opposite and the hypotenuse. Opposite over hypotenuse is sine, so we have that the sine of alpha is 39 over 60. Once again, we need to use an inverse trig function. So we will say that sine inverse of 39 over 60 is alpha. When we put that in the calculator, we get that alpha is about 40.54 degrees. Our last problem says a truss is an interior beam structure used for building the roof of a house. It is formed by two right angles. If the truss has a horizontal length of 30 feet and a height of 4.5 feet, find the angle of elevation for the truss. We want to divide the 30-foot length into two. We'll have 15 feet for each of our triangles. The height is 4.5 for both, and let's say that we'll call the angle of elevation beta. We can reduce this down to one single triangle, and because we have the opposite and the adjacent, we'll use tangent to find our angle. We know that the tangent of beta is 4.5 over 15. So if we use tan inverse of 4.5 over 15, we'll be able to find our angle. Tan inverse of 4.5 over 15 comes out to be about 16.7 degrees. Make sure you pay attention to, as you complete the homework and other assignments, pay attention to the wording of the problems. Some problems may ask for degrees, some problems may ask for radians, and all of them should tell you how many decimal places to round to.